Good morning. Today we are going to discuss about serverless computing. Serverless computing is a cloud model where service provider manages infrastructure, letting developers focus on code by running applications in response to events without provisioning servers and paying only for consumed resources. While servers still exist, the cloud provider handles them such that making it seem serverless for the user, often using function as a service for specific tasks. The key points of serverless computing are as follows. It is another model of cloud computation only. It follows pay-per-use approach, that is, user pays for consumed resources. Service provider provides highly scalable and automatic scaling of IT resources. It supports event-driven functions or modular programming. Resources, that is, computing power and runtime environment, will be allocated automatically by the service provider based on the requirement of the functions or event-driven functions. Functions will get executed as temporary containers. Resources will be allocated during execution of functions. Once the function execution is over, the resources will be deallocated. It is cost efficient model. Figure shows the serverless computing reference model. User applications will have many functions. Every function may perform some event. So, they are said to be event driven functions. These events will be executed using API gateway. Functions are executed as containers. Comparison of serverless computing with other cloud models. In general, cloud computing offers the following services: infrastructure as a service, platform as a service, and software as a service. Let me compare the way of allocation of IT resources in serverless computing with other cloud computing services like infrastructure as a service, platform as a service, and software as a service. First, let us discuss the allocation of IT resources in infrastructure as a service. User requests for configuration of infrastructure needed for his application, that is CPU, RAM, memory, etc. Service provider provides infrastructure. User takes care of the required operating system, middleware, runtime environment, and application. The user executes the application on the IT resources provided by service provider. Then, allocation of IT resources in platform as a service. User requests configuration such as computing resources, operating system, runtime environment, that is, infrastructure and platform. Service provider provides infrastructure, operating system, middleware, and compilers, that is, runtime environment. User writes application and executes application on top of runtime environment provided by service provider. Then, allocation of IT resources in software as a service. User requests configuration of infrastructure, required operating system, middleware, runtime environment, and application also. Service provider provides infrastructure, platform, and application. User simply executes application. Next is the allocation of IT resources in function as a service, that is serverless computing. User writes application in the form of event-driven functions, submits a modular application program to the serverless computing platform, that is FaaS platform. Service provider allocates required IT resources, that is infrastructure, operating system, runtime environment to the user based on the functions submitted. The allocation and deallocation of resources is performed for every function. User simply executes the application. As this is a highly scalable approach, this model is most cost efficient than the conventional cloud models. Types of serverless computing. Cloud computing offers three types of serverless computing. They are function as a service, database as a service, storage as a service. Let me explain them one by one. The first one is function as a service, FaaS. Function as a service is a serverless cloud model where developers write small event driven code as functions and the cloud provider automatically runs them without managing servers, handling infrastructure, scaling, and billing only for execution time, making it cost efficient for building microservices and event driven applications. It is a core part of serverless computing, letting developers focus purely on writing code logic for specific tasks triggered by events like API calls. With FaaS, you upload your code to your cloud provider and the cloud provider runs it for you. Depending on the configuration of your function, the provider scales it based on how many clients request it simultaneously and you pay based on how many times your code runs. Second one is database as a service, DBaaS. Database as a service is aptly named. Instead of maintaining a database server either on premises or on a cloud virtual machine, the cloud vendor supports the database server for you. You pay for the database as a service based on how much data you store and how often you access it. This may be less expensive than paying for a dedicated cloud server. Different cloud providers offers different products for database as a service. For example, Amazon's AWS offers several different DBaaS products including RDS and Aurora. Google offers cloud databases while Microsoft has Azure SQL database. The third one is storage as a service. SaaS. SaaS is on demand cloud storage. Like the serverless computing model in FaaS and DBaaS, you pay for the storage you need as long as you use it and each time it is accessed. Unlike the storage you buy when you set up cloud servers, you can use this storage anywhere. You can limit it to your cloud resources or you and your clients can access it from the internet. You can also specify what kind of redundancy or backups you need. Amazon's simple storage service, that is S3, is one of the most widely used storage as a service products. Azure Storage and Google Cloud Storage are two more examples of storage as service models. Now, let me explain about serverless computing architecture. The serverless computing architecture contains five key features. They are authentication, database, API gateway, file storage, and reporting. Let me explain these features one by one. The first one is authentication. Authentication in serverless architecture is a managed, decentralized security mechanism that verifies user identity and authorizes access without maintaining dedicated servers. It typically uses third party providers and API gateways to secure serverless functions. Second one is database. Database feature provides fully managed cloud native storage that automatically scales compute and storage resources up or down even to zero based on demand without requiring manual server provisioning or management. These databases, such as Amazon Aurora Serverless, offer pay per use billing, high availability, and native fault tolerance. The third one is API gateway. The API primarily refers to the use of an API gateway as the single entry point for client requests to backend serverless functions. This gateway acts as an intermediary managing all the typical tasks involved in running an API without requiring developers to manage underlying servers or infrastructure. Fourth one is file storage. File storage in serverless architecture refers to durable, managed, and extremely accessible storage services like AWS S3 or Azure blob storage that integrate with functions to persist data. Because serverless functions are stateless, these services handle file uploads, downloads, and storage without managing infrastructure, often providing auto scaling, high durability, and pay as you go pricing. The fifth feature is reporting. Reporting in serverless architecture refers to generating automated, event driven, or scheduled data insights, analytics, and reports using managed auto scaling services without managing infrastructure. It uses event based triggers to execute code, providing cost effective, scalable, and real time analytics by processing data from sources like S3, DynamoDB, or BigQuery. Step by step process of how the serverless architecture operates is writing function code, uploading to FaaS platform, managed infrastructure, event driven execution, task performance, ephemeral containers or temporary containers, compute time billing. Let me explain these one by one. First one, writing function code. Programmers first writes the application code as a set of independent functions packaged in a container. The application is a modular program. Each module is an event driven function. The second one, uploading to FaaS. Once the application is developed, the code of application, which is in the form of functions, are uploaded to serverless computing platform, that is on a FaaS platform such as AWS Lambda. Third one is managed infrastructure. The cloud provider allocates required infrastructure and runtime environment to run the function as a container. The allocation of infrastructure and runtime environment is based on function by function. Fourth one is event driven execution. The API gateway takes care of the execution of functions as containers. The function may be an inbuilt function or an external function. The cloud provider executes the functions triggered by an event as temporary containers. Fifth one, task performance. The functions perform their respective roles, such as integrating with third party services. Sixth one, ephemeral containers or temporary containers. A temporary container that gets triggered during invocation and destroyed after the execution completion. The cloud provider handles its creation and destruction automatically. The last one is compute time billing. Companies taking the serverless computing services have to pay according to the time consumed while executing the functions. Advantages of serverless architecture. The following are the advantages of using serverless computing: cost efficient, increased scalability, faster time to market, flexibility, speedy code execution are the advantages of serverless architecture. Let me explain the advantages one by one. Cost efficient. You need to pay only for the resources used at the time of execution of functions. Thus, licensing fees, hardware expenses, and maintenance cost is saved associated with the cloud architecture. Second one is increased scalability. The resources are easily scaled up or down as per the varying requirements. Serverless platforms automatically create or delete function instances in response to varying traffic without any manual configuration. Next one is faster time to market. Serverless environments increase the deployment speed. Next one is flexibility. Applications built using existing services are easy to adapt to emerging needs, thus increasing agility in the development. Next one is speedy code execution. The vendor can run the code on servers near the end user, hence, users receive faster responses to their requests. No origin server is involved here for hosting the application. The limitations of serverless architecture are as follows. First one, vendor lock-in. Second one, not suitable for long running processes. Third one, cold start latency. Fourth one, limited control. Let me explain the limitations of using serverless architecture one by one. First one is vendor lock-in. Most cloud providers not allowing portability in serverless computing. There are chances that you cannot switch between multiple cloud providers if necessary, as you are reliant on a particular provider for all the managed services. Second one is not suitable for long running processes. You are charged based on the computation time. Hence, long running workloads may prove costly in serverless computing. Cold start latency. Functions invoked after a period of inactivity take time to execute as initializing a serverless environment takes time. Next one is limited control. The use of a serverless platform is subject to the terms and conditions of the provider. Thus, user has very little or no control over the server hardware infrastructure. Now, let me explain the serverless computing with an example. If we consider the application of an online order, for example, assume that the application contains three modules: authentication module, payment module, and ship goods module. The modular application is submitted to the FaaS platform. The functions get executed through API gateway. First, authentication module is executed as a container. Then, payment module is executed as a container. And then, ship goods module will be executed as a container. Whenever it executes a container, infrastructure will be assigned and released after completion of execution of that particular function. Key components of serverless computing. Serverless computing relies on four core components that work together to support event driven execution, seamless scalability, and efficient resource management. These components form the backbone of the serverless model, ensuring that applications can respond quickly to demand without requiring manual intervention. They are function as a service, event sources, API gateways, managed backend services. Let me explain this one by one. First one is function as a service, FaaS. FaaS is a heart of serverless computing. It allows developers to write individual functions that execute in response to specific events. Instead of deploying entire applications or services, developers deploy small, isolated pieces of logic. These functions run only when triggered, scale automatically based on workload, and incur costs only during execution. This granular approach promotes flexibility, modularity, and faster development cycles. Next one is event sources. Event sources are the triggers that initiate serverless functions. They can be anything from HTTP, that is Hypertext Transfer Protocol requests and database updates to file uploads, message queue events, or timed schedules. These events act as signals for the cloud provider to launch the appropriate function instantly. The tight integration between event sources and functions enable real-time responsiveness and makes serverless ideal for event-driven architectures. Next one is API gateways. API gateways serve as the communication bridge between client applications and serverless functions. They manage incoming API requests, route them to the correct function, and handle key processes such as authentication, rate limiting, request validation, and response formatting. By offloading these responsibilities to the gateway, developers can build robust, secure APIs without managing additional backend infrastructure. Next one is managed backend services. Serverless architectures often rely on fully managed cloud services like databases, message queues, storage solutions, and authentication systems. These services eliminate the need for manual configuration, patching, or performance tuning. By integrating seamlessly with the serverless functions, they help create complete applications that are scalable, efficient, and easy to maintain. After outlining the foundational components, it is time for us to understand how serverless computing works in detail. How serverless computing works. Serverless computing works through a cloud managed architecture that automatically handles request processing, execution, and scaling without requiring developers to manage servers. This architecture brings together managed services that coordinate seamlessly to run application logic only when needed. Let us have a step by step breakdown of how serverless computing works within this architecture. They are Step 1 user request. Step 2 request handling. Step 3 access control. Step 4 function execution. Step 5 service integration. Step 6 response and cleanup. Let me explain these steps one by one. Step 1 user request. A user initiates an action within a web or mobile application, such as submitting a form, requesting content, or triggering a background operation. This integration generates an event that starts the serverless computing workflow, allowing the application to respond dynamically without maintaining continuously running servers. Step 2 Request handling. The incoming request is received by the API gateway, which acts as the primary entry point in the serverless computing architecture. It is responsible for routing requests to the appropriate backend services, managing traffic flow, enforcing rate limits, and performing initial request validation to maintain performance and reliability. Third step is access control. Before any backend logic is executed, authentication and authorization mechanisms verify the identity of the user or system making the request. This step ensures that access policies are enforced consistently, protecting sensitive operations and data while keeping security management abstracted within the serverless platform. Step 4 Function execution. Once access is granted, a serverless function is invoked to execute the application's business logic. The cloud provider automatically provisions the required compute resources, runs the function in an isolated environment, and handles scaling transparently, allowing the function to respond efficiently to varying workloads. Step 5. Service integration. During execution, the serverless function may communicate with other managed services such as databases, messaging systems, or external APIs. These integrations enable the function to retrieve data, perform processing, and store results, supporting complex workflows while maintaining the flexibility of serverless computing. Step 6. Response and cleanup. Once processing is complete, the function sends a response back to the client using the API gateway. The cloud provider then immediately terminates the execution environment and releases all allocated resources, ensuring efficient resource utilization and billing based solely on actual execution time and usage. Top serverless computing platforms. There are a variety of serverless computing platforms that provide developers with the tools and integrations needed to build event driven, scalable, and cost efficient applications. Among them, the most widely used ones are AWS Lambda, Azure Functions, Google Cloud Functions. Let me explain about public cloud, that is AWS Lambda. AWS Lambda is one of the earliest and most established serverless platforms, widely recognized for its deep integration with AWS ecosystem and its ability to handle workloads of all sizes. It allows developers to execute code when specific events occur, making it ideal for automation, data processing, backend services, and real-time applications. Lambda's strong global presence and consistent performance makes it a popular choice for enterprises seeking robust serverless capabilities. The key features are broad language support, which offers multiple runtimes including Node.js, Python, Java, Go, Ruby, and .NET. Seamless AWS integrations works closely with the services such as S3, DynamoDB, Kinesis, and API Gateway. Automatic scaling spins up additional function instances based on demand without manual configuration. Detailed monitoring provides logs and metrics through Amazon CloudWatch for performance insight. Azure Functions. Azure Functions is Microsoft's serverless offering designed to help teams build highly connected applications that leverage the full power of Azure Cloud. It supports an extensive set of triggers and bindings, allowing developers to integrate with databases, queues, and event streams with minimal effort. Azure functions are especially well suited for enterprise environments where .NET, Active Directory, and Microsoft development tools are commonly used. Key features: rich development environment, triggers and bindings, durable functions orchestration, flexible hosting. Google Cloud Functions. Google Cloud Functions provides a lightweight and developer friendly environment for building event driven and cloud native applications. It excels in scenarios that require quick deployments, automatic scaling, and tight integration with Google Cloud Services. Its simplicity and minimal operational overhead makes it ideal for real-time data processing, backend APIs, and automation tasks in modern application architectures. Key features are multi-language support, deep Google Cloud integrations, fast deployments, and smart auto scaling. Let me explain the open source serverless computing platform OpenFaaS. OpenFaaS is a popular open source framework that specifies the deployment of event driven functions and microservices to Kubernetes or other container orchestrators like Docker Swarm. It provides a portable, easy to use platform for running code in a serverless manner without requiring developers to manage the underlying infrastructure. OpenFaaS was created by Alex Ellis in 2016 as a solution to the challenges he encountered while deploying and scaling applications in a cloud native environment. Figure shows the architecture of OpenFaaS serverless computing architecture. It contains an API gateway, Kubernetes orchestration to manage the container functions when events invoked. Comparing OpenFaaS with other serverless computing platforms like AWS Lambda, etc. Compared to proprietary solutions like AWS Lambda, Google Cloud Functions, and Azure Functions, OpenFaaS offers significant advantages primarily revolving around portability and openness. Unlike proprietary solutions that often impose vendor lock-in, OpenFaaS runs on any environment that supports containers, including popular container orchestration platforms like Kubernetes and Docker Swarm. This ensures user is not tied to a single cloud provider. When compared with other open source serverless frameworks such as Kubeless, Fission, and Native, OpenFaaS strength lies in its simplicity, community support, and breadth of its features. That's all about serverless computing, and in the next video we will discuss about Internet of Things using cloud computing.